Hello, everyone. In this video, the first thing that I would be doing is describing some key terms, which are the population, sample, population parameter, and sample statistic. And then after that, we start talking about the sampling distribution. So what is the population? More correctly, we say statistical population. So a statistical population, or simply a population, is the collection of all observations or measurements of a trait or characteristic of a group of units, which could be a group of people or group of objects. So when we have a population, what we mean is that for a population there is a group of units of interest. So this is a group of people, of objects, and then a trait or a characteristic of that group would be under investigation, and then you have measurements of that trait. And so the collection of all measurements is the population. So as an example, the group of people that I can take would be, let's say we have all the males in Sri Lanka. So that's my group of units, or it's my group of people or objects. And then a trait that I want to investigate is, let's say, height. And then if I collect if I collect the measurements of height for all the males in Sri Lanka, that's the population. So here is another example. In this example, the group of units would be 1 gallon cans of paint. So imagine that a manufacturer, they are producing this 1 gallon cans of paint, and the trait that we want to, so the group of objects here that we are interested would be these cans, and then the trait that we want to investigate, let's say, is the coverage of area. How much area can be covered by 1 gallon of paint. And so what would be the population here in this example? Well, imagine for all the cans, you calculate the coverage area, and then you create a set of all these measurements, and that's the population in this example. Now, sample is simply a subset of the population. So in example 1, when we take males in Sri Lanka, we are studying height. So usually you use, population isn't something that you really compute out, because there are too many males. So usually you take a sample to say something about the population. So you take a sample. So what it means is that you have, you pick a let's say 1,000 or 500 males in Sri Lanka, and for each one of them you measure the height, and then you take a set of those 500 measurements, and that's a subset of the population, and that's the sample. Now, to ensure that sample is representative of the population, and to have a framework in which probability theory can be applied, we need to pick a random sample. That is, when you're picking a sample, for example, it shouldn't be done by convenience. So it should be done in a random fashion. So if you don't pick your sample, a random sample, then there would be inherent bias in your sample. So we model the observations of a sample size. We model the observations of a sample of size n as random variables x1, x2 to xn. So, which means that x1 is the first measurement in the sample, x2 is the second measurement in the sample, and xn is the nth measurement in the sample. And so here you imagine that you are imagine in the example of the males in Sri Lanka, and we are studying height. Imagine that you pick a male in Sri Lanka randomly, and then you measure his height, and that's going to be x1, and then you pick a second person, you look at the measurement, and so on until you get n measurements. And then when you take after you pick one sample, maybe you take another sample. So when you pick a second sample, the values of x1, x2, xn, they change. So you can think of this variables as random variables. And then when we say a random sample, then we mean that these variables x1, x2 up to xn, they are independent and identically distributed. That is, they all have the same distribution as a random variable, and they are also independent. And a small x1 up to small xn, they will denote the observed values of this variables x1 up to xn. Okay, so that's what a sample is. Now, what's a parameter? A parameter is a quantity which is calculated on the basis of the entire population, such as mean and variance. So if we go back to example 1 here, one parameter could be the average or mean height of the males in Sri Lanka. So imagine that you have the measurements of height for all the males in Sri Lanka, and then you can calculate the average height. So that would be a population parameter. And then you can also talk about the variance for the measurements in the population. So that's a parameter. It's a quantity based on the entire population. What's a statistic, or more appropriately, sample a statistic? Well, it's a measurement that is based on a sample, such as a sample mean or a sample variance. So if you pick a sample of size n, so then let's say you pick a sample of size 500. So you pick 500 males in Sri Lanka, and then you measure their heights, and then you take their average height. Well, that's a sample mean. So that's a sample statistic. Or you can also calculate the variance of for the measurements of height for the 500 males in the sample, and that's also a sample statistic. Okay, so we just so far what we have done is describe what is the population, what's a sample, what's a parameter, and what's a statistic. In the next video, we will start talking about the sampling distribution. See you then.